This is Senior Project Group FPGA based logic analyzer. So first, to show off the demo, we're going to just launch the GUI. You can see the GUI now here, so I'm going to hide the command window. Now that the GUI is launched, we can come over to the config. We can change some modes so that you'll be able to see some LEDs change on the board. So we'll change it to trigger on the sampling clock, channel 7, and we'll put the PWM duty cycle to 0.5. Then we'll come back to the control tab. We'll connect to the logic analyzer. We'll update the configuration settings. We'll send the configuration settings. You'll now see some of the LEDs on the board have been changed. We can reset those changes to go back to the default values to see some other ones. We can send the PWM. If you measure with the multimeter, you'll see it measures about 1.6 something volts because half of 3.3. If we go back to the config page, we can change the PWM to 0.1. Come back to the control page and send the PWM. You'll now see the LED is much dimmer. We can clear the PWM, and then we can go back to the config, go back to our default settings. This is trigger on any change. So then we can hit start, and we can plot the data. So as you can see here, we can zoom in on the plots. So if we keep zooming in, we can see the SPI signal here. This is our S clock channel. This is our CS channel. This is our MOSI channel. This is our MISO channel. Now that we've seen that plot, we can go back to the GUI. And the command window. I'm going to keep the command window down here. So if we go over to the decode page, we know this is an SPI signal, so we know that, let's see, S clock was channel 3, CS was channel 0, then we have MOSI was channel 1, MISO is channel 2, and that's pretty easy to see if we just look here, S clock, MOSI, CS, and MISO. We're just matching those up so that we can decode them. Okay. Now we can just hit the decode SPI, and you can see it decoded those packets. So we see it sending FA, F7, FD, which is just saying I want the temperature, I want the pressure, and I want the humidity. And this is just the reply the temperature, pressure, and humidity sensor is sending back, which is neat. After that, what we can do is we can go through here, and we can actually export that as a CSV if we want. I'll go ahead and do that now, and it just exports into the working directory. Now, since we use logic analyzers for more than SPI, we can import a CSV, which if I hit that button, you can see the file explorer popped up. So I can navigate to some old captures I did. So here's an I2C capture, and then we can plot that capture. Go back to just Chrome being popped up. And if we zoom in on one of those, here we can see the I2C transaction. We can also decode that. So if we go to the decoding page, back into the GUI, so we know that SCL happened to be channel 0, SDA happened to be channel 1. We can decode SPI. You can see that it is basically just reading requesting to read address 76. It's acknowledging, This is saying I want to read the, down here is saying I want to read the temperature. This is reading it. This is the temperature that it read. It's saying it's done. That's working. If we want to look at another one, we can come back over here, import another CSV. This is a UART transmit. We'll have to change the mode that was done. Yep. Okay. Update the config. And then if we plot that, we have the UART transmit data. So if we come back to the enter command window, go over to our decoding. So that was on channel 1 and channel 0. We have no RX, and the baud rate was 9600 bits per second. So if we decode UART, oh, I'm scrolled up. Yep. You can see it decoded as that and that, so 304130 in hex. Another neat feature we have is that we can actually go back to the control page, hide the command window, and then we have this export pulse view button, which is just a button that allows us to use an open source software to visualize. Once that launches, I'm going to have to hide a bunch of windows. Okay, so this is the open source software, which comes with a bunch of decoders that we can also access. So in this case, I want the UART decoder. I know that the TX line happens to be channel 1. I know that it's not that. Data bits, parity, okay. And you can see we get the same 30, 41, 30, which is the same thing we got before.